Hi everyone, my name is Allie. It is March 12th, 2022, and I am going to be discussing my Unit 2 case connections. So today I am going to be discussing case number 2 and case number 3. Let's start with case number 2. A 16-year-old female is recently diagnosed with a deficiency of muscle glycogen phosphorylase. She and her family are concerned and ask the following questions. Now, before I get started, I do want to say that throughout this video, I will be using the term McArdle's disease interchangeably with a deficiency of muscle glycogen phosphorylase. McArdle's disease is the name of the condition resulting from a deficiency of muscle glycogen phosphorylase, and it's just easier to say. So let's talk about the questions her and her family might have. Question 1. I'm not sure I understand the issue. Can you explain how muscle glycogen is used during exercise? Certainly. During exercise, our muscles use a form of energy called ATP to contract. ATP is derived from glucose molecules that have been oxidized from glycogen stores in skeleton muscle. The process in which glycogen is broken down into glucose for use in our metabolic pathways is called glycogenolysis. Thus, muscle glycogen is the foundation of any muscle contraction, as it provides the materials for the energy of that contraction. Glycogen phosphorylase is the enzyme that mobilizes the breakdown of glycogen into glucose 1-phosphate monomers for energy. Without this enzyme, the glycogen stores remain in the skeleton tissue rather than being made available for use by the body. Without available glycogen, the process of glycogenolysis cannot occur, and there are no glucose molecules available for the production of ATP. Deficiency of muscle glycogen phosphorylase, the enzyme that makes glycogen available for the production of ATP, results in fatigue and an increase in muscular pain. So, second question. I really like to take long walks. Will I still be able to do this with my friends? Let's talk about how glycogen stores are used during exercise. Glycogen stores are used during prolonged bouts of exercise. Because a deficiency of muscle glycogen phosphorylase results in a lack of available glycogen for energy metabolic purposes, long walks might take a toll on this patient's body, especially if the walk happened sometime after eating. The first 15 minutes of the walk would be pretty grueling due to overall fatigue as well as muscle pain. However, there is a second wind effect that occurs as exercise progresses, which happens when the body's preferred fuel source for exercise moves away from glycogen stores, which are not available in patients with McArdle's disease, to free fatty acids, which are not affected by a deficiency of muscle glycogen phosphorylase. Some of these free fatty acids are stored as triglycerides in the muscles, though a majority of these free fatty acids are derived from adipose tissue. So basically, the first 15 minutes of the walk would be very, very grueling because glycogen would not be available for ATP production, which would affect muscle contraction. However, when the body switches over to a different source of energy, aka using free fatty acids, there would be a different feeling and exercise could continue. In general, for this patient, my advice would be to take small walks with rest and to constantly fuel during these breaks. However, if she wants to experiment with the second wind effect, she could try to push through a painful beginning of the walk to get to that easier stage of exercise, which is common for patients with McArdle's. Third question. As a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels? So, Glycogen is stored for times that your body is doing strenuous activities and needs more fuel. Or I should say glycogen is stored in skeletal muscle for times that your body is doing strenuous activities and needs more fuel. A deficiency of muscle glycogen phosphorylase affects your body's ability to utilize these stores when the body needs it by affecting your body's ability to generate the energy currency for muscles, known as ATP. However, when we are sleeping, our bodies are not engaging in strenuous activity and do not need constant energy supplied to muscles to initiate contraction. Thus, glycogen stores are not as needed during sleep. If you fueled well during the day, your body will have enough glucose to function throughout the night. However, it is recommended to have food by your bed just in case. Fourth question, do I need to worry about producing excessive lactate during intense anaerobic exercise? Overall, intensive exercise is not recommended for patients with muscle glycogen phosphorylase deficiency, as patients with McArdle's disease do not have an adequate metabolic pathway to sustain this type of exercise without fatigue or pain. So my initial answer is that lactate should not be a concern because intense anaerobic exercise should not be attempted by someone with the deficiency of muscle glycogen phosphorylase. However, based on my research, patients with McArdle's disease produce less lactate than is taken up for oxidation. And new findings are also indicating that lactate can be used as an energy source when glycogenolysis is impaired. A study published in the Journal of Clinical Endocrinology and Metabolism actually suggests that lactate supplementation might help patients with glycogen storage diseases like McArdle's. These findings also point to a decreased worry of lactate buildup during exercise. So I would say that you don't need to worry about lactate buildup during exercise, but also don't attempt intense anaerobic exercise if you have McArdle's disease. Okay, let's move on to case number 3. A 5-year-old boy is brought to the pediatrician's office for an annual visit. The mother reports he has been a sickly infant and often appears drowsy. She has concerns over her son's persistent thirst and frequent urination. What does this information likely suggest about the underlying biochemical basis for the patient's symptoms? The symptoms of the 5-year-old boy, specifically drowsiness, constant thirst, and frequent urination, are in line with symptoms of hyperglycemia. Hyperglycemia is a symptom commonly associated with diabetes. Diabetes mellitus, or type 1 diabetes, is a result of the destruction of pancreatic beta cells, the cells that produce and manage insulin in the body. The destruction of pancreatic beta cells affects the overall functioning abilities of the pancreas, including an impact on the pancreatic alpha cells, which produce glucagon. When glucagon is not suppressed, blood sugar levels are raised, leading to high blood sugar or hyperglycemia. The kidneys are not able to absorb the excess glucose, and there is a spillover of the excess blood sugar into urine. Glucose has a high attraction to water, and higher levels of glucose in urine result in frequent urination. Frequent urination also triggers dehydration. The symptoms described by the patient's mother, specifically increased urination, dehydration, and general sickliness, are in line with the symptoms of hyperglycemia, a symptom of diabetes mellitus. Given that the patient is young and because his bodily processes seem to be a result of impaired pancreatic function, we can reduce that it is type 1 diabetes. The result of the glucose loading test also confirmed that the patient has diabetes. The baseline blood sample from the patient indicated extremely low serum insulin levels, which already suggests that the patient's body experiences impaired glucose tolerance. 1 hour after the glucose load, the patient still had extremely low serum insulin levels, roughly 1/8 of the serum insulin levels of the control sample. The patient is young, and the patient's mother describes him as sickly. These demographics, along with the results from the glucose loading test and the hyperglycemic symptoms, point to a diagnosis of diabetes mellitus or type 1 diabetes. What would you predict the patient's fasted blood glucose to be given his current condition? Because these cells, the pancreatic beta cells, are not producing enough or any insulin, the body has a damaged glucose intolerance. This would result in a fasted glucose level above the normal range, as the patient's body is not producing enough insulin to help his body absorb glucose. The inability to absorb glucose from the blood means that there will be a high level of glucose still present in the blood, putting the patient's fasted glucose level above the abnormal range. Based on this diagnosis, what two regulatory enzymes are likely to be active in this individual's current condition? Given the patient's current condition, it is likely that the enzymes phosphofructokinase and hexokinase would be increased or elevated. Phosphofructokinase is inhibited by ATP and glucagon. ATP and glucagon are products of the metabolism of glucose, pathway that is impaired in this patient's body. This would mean that there is more phosphofructose kinase. Hexokinase has an increased affinity for glucose and responds to rising levels of glucose in the body. Since this patient has a high glucose level above the normal range, it is likely that hexokinase activity will be elevated. That's all for tonight. Thanks so much.